In today's video, we are going to know about big G and small g. What is big G? What is small g? What is the difference between them? How to write their formulas? How to solve numericals? We are going to understand all this in today's video. So let's start off by understanding the concept. What is the concept? That every particle in this universe attracts every other particle in the universe. For an example, I am having an attraction. I am attracting this pen. I am also attracting this board, and the same way the board is also attracting me. This is the concept of universal law of gravitation, that every particle possesses an attractive force towards the other particle, right? Universal law of gravitation. Now we also have a formula in this, that is F is equal to G into M1 into M2 whole divided by R squared. Simple formula. What is this formula? How is this formula derived? How to solve this formula? Everything you will know about this in this video. So, what is F? What is G? What is M1? What is M2? Let's understand. If I have two objects here, two balls, this is ball A, this is ball B. This ball will contain some mass, right? For an example, this ball has a mass of 5 kg, this ball has a mass of 7 kg. Now, what will be the attraction? What will be the force of attraction? What will be the magnitude of attraction between these two balls? We can find out using this formula. What did I say? What is the magnitude of attraction between two objects? We can find out using this formula. Now, these two balls will have some distance between them. That distance we represent as R. And whatever distance we are having between these two balls, we need to square it. R into R, R square. Simple. Now what is this G? The main thing. This G has a specific value, and that value is 6.67 into 10 raised to minus 11. It also has a unit which I will be explaining in the later part of the video, but the value is this. Now, how is this value derived? Let's understand. This value is derived. How it is derived? Let's understand. If there are two balls of 1 kg each, right? एक किलो के दो बॉल रखे. If there are two balls of 1 kg each and they are separated by 1 meter, the gravitational attraction between those two balls will be equal to 6.67 into 10 raised to the power of minus 11. What is this concept? If there are two balls, both are of 1 kg and are separated by 1 meter of distance, they will have an attraction force of 6.67 into 10 raised to the power of minus 11. This thing also has a unit, and I will be explaining this unit in the later part of the video. So for now, your concept must have been clear about the force, which is equal to Gm1 and 2 by R square, and through this formula we will be deriving the formula of small g. Now, formula of small g will be here Gm by R square. Here another m which is present will go off, and why it will go off, how it will happen, we will be learning in this video. Now let us understand about the unit of the big G. So the formula of the big G was F into G into M1 into M2 by R square. Now the unit of force is newtons, right? But what is the unit of this big G? Let's find out. How to find units is a very simple thing. Now we will bring this R this side, so it will be F into R square. This M1 M2 will go down, M1 into M2 just like that is equal to G. Now the unit of this is what? Force is what? Newtons. R क्या है? R है हमारा मीटर स्क्वायर, राइट और रॉन्ग? Then we got this kilogram also squared, y squared, anything multiplied by itself, then it will become a square. Now what will this give? Newton meter square upon kg square. If you do not want to write like this, you can write Newton meter square kg raised to minus 2. This is the unit of this big G. How to derive this unit? I just told right now. Newton into meter square all divided by kg square, right? This is the unit of big G. Now we are going to talk about small g, and as I said, through that big G formula we can actually find out small g. How to find out? I will be telling you. Now here we have force is equal to 6.67 into 10 raised to minus 11. That is the constant value of what? Value of this big G. Now what does this tell us? Value of big G is what? Simple. अगर दो बॉल है, दो बॉल दोनों 1 किलो के हैं, उनके बीच में 1 मीटर का डिस्टेंस है, तो फिर उन दोनों के बीच में कितना अट्रैक्शन होगा, उसकी वैल्यू है ये 6.67 into 10 raised to minus 11 into we have 5.96 into 10 raised to 24. Now what are we trying to find here? We are trying to find here small g. But for a moment forget that through this formula we are going to find small g. Let's assume a situation that this is our planet Earth and I have kept this box X. This box X I have kept here, which is of 1 kilogram. Now I need to find the attraction, the amount of attraction, the magnitude of attraction between this 1 kilogram box and this whole planet Earth. By how much force does this Earth attract this 1 kilogram box? Right? Let's find that. So for finding that, what values do we need? We need this G value which we have. Another value we need is the mass of the Earth. Now what is the mass of the Earth? Mass of the Earth is 5.96 into 10 raised to 24 kilograms. Now here we have the mass of the Earth. Nice. Now what else we need? Mass of the object, which is 1 kilogram, that box. Then whole divided by what we had in division? We had r square. R is the distance squared. Now Earth is spherical, or actually geographically Earth is an oblate spheroid, but if we need to solve this equation, we need to take Earth as a sphere. Now the distance, the r between the box and the Earth will be its radius. Right or wrong? Any spherical object, where is the Earth? What will be the distance? Radius. Twice of radius is known as diameter, right? Right now, twice of radius is known as the diameter. Now here from the center to the boundary, we are actually neglecting the space which is above the earth's crust and the object. Why are we neglecting? For the simplicity of calculation. And by the way, this r is not the same. As you know, earth is bulged at the equator, so there is more distance from the center point of the earth to the sides of the equator than from the poles. So this is just a round figure value. It is not an exact value. So here we have the r. But for this sum, let's assume that it is 6.37 into 10⁶. Now, we need to square this 6.37 into 10⁶. If we square this and solve this entire equation, we will get the answer as 9.8 newtons. What will be the answer? 9.8 newtons. इस पूरी कथा का जवाब क्या है? 9.8 newtons will be the value of your small g. But for simplicity, many students take this 9.8 newtons as 10 newtons. Why? Because it is simple for calculation. Now you have entirely understood the concept of big G and small g, the formulas, the derivation, how to solve numericals, कैसे आया, क्यों आया, ये रेडियस कब हुआ, इसकी सारी फॉर्मूलाज आपने समझ लिए. Now let us understand the difference. By this point of time, you might have already noticed many differences between small g and big G, but let's write it down for our knowledge. I am not making a line, I am just explaining on the board like that. Now, the value of this small g, 6.67 into 10⁻⁻11 Newton meter square kg minus. This value will never change. The value of this big G is never going to change. That is why it is called as universal law of gravitation. That is why it is ULG. This value is never going to change whether those two balls are in space, are on Mars or on Earth. This value is never going to change. Whereas the value of this G, 9.8 newtons or 10 newtons, you can say, Newton per meter square. This value is going to change. Why it is going to change? Because this value is what? This value is the acceleration. Now, in my last sum, you might point out, right, that I have found 9.8 newtons. How am I writing 9.8 Newton per meter square? It is the value of acceleration, right? This is gravitational acceleration. And in last sum, we were finding the force between them, if you remember. But anyways, this is about gravitational acceleration, and this changes from place to place. This also changes when you are on different place on Earth, but your measurements are not accurate. That's why on Earth we take this 9.8 newtons. But on Moon, if you go, whose mass is 1/6 that of Earth, this value is also going to be less. The gravitational acceleration, of course, will change. Why? Because the entire body is changing. But in the case of this big G, it is never going to change. So friends, this was all about big G and small g. We learned about the main differences between them. We learned about how to find their values. We learned how to put their values, what is r square, everything. We also learned how to derive the units of big G. We learned so many things in this small 11-12 minutes video. So if you like the video, then do subscribe to my YouTube channel, and also the links to my previous video are given in the description box below. So be sure to check those videos out. Thank you.